This is half past paper week 12 for the higher tier. Again, we've got all the topics here that we're going to go over today with some really tricky grade 9 questions on the end of this paper. 38 marks for this one. Remember, all the odd numbers of this paper were last week. So if you haven't done week 11 yet, go and give that a go. And this is week 12. So there we go, half a past paper. Question number 2, and we've got compound interest. Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get at the end of the 4 years. So compound interest normally comes up more on the higher paper, but it is on foundation here. We've got 200,000 in a savings account for 4 years. Now, interest is extra money the bank give you as a little thank you for having your money with them. It's like an incentive to use their bank. You always get to keep 100% of your money, of course, and you get an extra 1.5% per annum, which means like annual, means per year, for having your money in that bank. So therefore, altogether, each year, we're going to get 101.5% of what we had the previous year. Now, we just saw in the previous question that to get a percentage, you can turn it into a decimal and times by that. So if I turn this into a decimal, it would be 1.015. To go from a percentage to a decimal, you divide by 100. 100% is 1. So 101.5% is 1.015. So I'm going to multiply by 1.015. And then we'd need to times it by 1.015 for the second year, and then times it by 1.015 for the third year, and then times it by 1.015 for the fourth year. So altogether we can just say that's to the power of 4 because we're doing this for 4 years. Typing that in your calculator, 200,000 times 1.015 to the power of 4. And now is where we really need to carefully read the question, because a lot of students missed the 7101, but it's money, so I'm going to just do 2 decimal places. Check the next number, yeah, that rounds down. So £212,272, 71 pence, but it didn't ask you how much money is now in her account. It said calculate the total amount of interest. So we actually now need to take the 200,000 that she originally put in back off. So therefore, in total, the total amount of interest that she got was £12,272 and 71 pence. You would have lost a mark for not doing that final step. All about checking the question, reading the question, making sure you're doing what they're asking of you. Question number 27. Now, this was quite a tricky one. Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. The number of visitors in thousands here on the y-axis, so this is going up. Now, I remember marking this one back in 2019, and a lot of students said, oh, they didn't put thousands on the axes. That's okay, there's nothing wrong with that. It clearly says thousands here, so that's okay, we're okay with that. The thing that you needed to spot is said write down 2 things that are wrong or misleading with the graph. Now, this graph is talking about number of visitors to a fun park in thousands. We've got 2016, we've got 2017, and we've got 2018. And the numbers, the 2, the 3, and the 4, we can assume that they relate to the quarters of the year. So the first quarter of the year, the second quarter of the year, the third quarter of the year, the fourth quarter of the year. And consistently, there is no one. I mean, I would assume, we don't know, that the theme park maybe wasn't open from January to March, maybe, or from December to February, or those kind of winter months, and that's why there's no data for the first part of the year. But we don't know that. We want to look more at bigger things that are wrong with it. I will read you all of the different answers from the mark scheme. There's quite a lot of options on there. The biggest thing I can spot that's wrong is that it goes 6, 6.57, 7.58, 8.59, and then 10. So the first thing I'm going to say is 9.5 is missing from the y-axis. I'm going to be really clear about where I'm expecting to see it. I'm expecting to see it here, well, where the 10 is really, and it's not there, so that's not right. It has to be a linear scale on each of the axes, okay? The other thing, let me read through these. The other thing they would have allowed is that the y-axis did not start at 0. So let's put that y-axis did not start at 0. It starts at 6. They allowed that. So let me read through all the reasons. You were allowed, the first quarter is not shown, plotted or labelled. It does not show all 4 seasons. You were allowed 9.5 is missing from the vertical axes. You were allowed the vertical axis does not start at 0, or the y-axis does not start at 0. The graph does not begin at 0 was okay. It's not clear what 2, 3 and 4 on the x-axis mean. You were allowed to say that. The scale of years does not make sense. You were allowed to say that. And you were allowed to say there is a lack of clarity about what the numbers on the x-axis represent. So those 2, 3, 4, it doesn't really say what they are. We're assuming they're quarters of the year, but we don't really know. Okay, it was not acceptable to say 0 is missing, because we wouldn't have expected the x-axis to start from 0 anyway, so you needed to say the y-axis to get that mark. It wasn't acceptable to say they shouldn't have connected the dots like that. It wasn't acceptable to say the numbers on the x-axis are repeated. It wasn't okay to say the numbers along the x-axis 2, 3, 4 and not say anything else about it. The years on the x-axis have not been written properly. That wasn't allowed. It does not follow a sequence. That wasn't allowed. It needs a discontinuity wiggle on the axis, so they mean this thing. That didn't get you a mark. And no title. You wouldn't believe how many students say to me no title. Also, the one I saw a lot when I was marking was about the thousands like that. You weren't allowed that either. So there we go. That was 2 things wrong with it, but ultimately not the loveliest graph. But always check your axis, what it's going up in. This is your y-axis, this is your x-axis, and make reference to those when you're talking through your answer. Okay, question number 29. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 and a height of 1.8. Jeremy has 7 tins of paint. Each tin of paint covers 5 meters squared. Has Jeremy got enough paint to cover completely the 3 tanks? You must show how you get your answer. So I think it's going to be helpful if we roll this out. So we are painting the outside of this. So I'm going to unroll it to see the net of it, because I think that's going to help a lot of people to visualize what we're doing. Now the area of the circle is pi times the radius squared. So we need to do pi times the radius squared for the top of this cylinder and pi times the radius squared for the bottom. We know that this is the height of a cylinder, which is 1.8. But this distance along here, how would I get that? Well, that is the same as the distance around the edge of the circle, so the circumference. And we get the circumference by doing pi times diameter. So taking all that into consideration, the circle on the top is going to be pi times 0.8 squared. 0.8 because we're only going to the middle for the radius. If it's 1.6 all the way across, it's 0.8 to the middle. And then pi times 0.8 squared for the bottom as well. So we've got that one to do, and we've got that one to do. For the rectangle, I want to do pi times diameter, which is pi times 1.6, times by 1.8. And timesing all of that together is going to get me the area of that rectangle. So let's start with pi times 0.8 squared. And that is 2.010619298. Notice I'm writing lots of decimal places here. I don't want to round anything until I get to the end. And I've got the same for the bottom circle, 2.010619298. I also want to do pi times 1.6 times 1.8. That's the area of the rectangle. Pi times 1.6 times 1.8 is 9.047786,842. So these 3 values added together are going to get me the total surface area of each cylinder. Adding all of those values together, I get 13.06902544. Now that's the surface area of 1 cylinder, but I want the surface area of 3 cylinders, so I'm going to times that answer by 3. It says in the question that he's got 3 tanks to cover in paint. So I'm going to times that answer by 3, and that is 39.2070763. Now, each tin of paint covers 5 meters squared. So he's got 7 tins of paint. So 7 tins of paint, 5 meters squared, means that 7 times 5, he can cover 35 meters squared. But our tanks are 39.2. The question is, has Jeremy got enough paint to completely cover the 3 tanks? And the answer is no, he does not have enough. Great, and you could even say 35 is less than 39.2 if you really wanted. Question number 8. ABC is a right-angled triangle. Here is Sarah's method to find the length of BC. She's done BC squared is AB squared add AC squared. So she's done Pythagoras. She said 6 squared add 8 squared is 100, and she square rooted that to get 10. What is the mistake that Sarah has made? So Sarah has assumed that this is the hypotenuse. And it isn't. The hypotenuse is over from the right angle. This is actually the hypotenuse. This is the longer side of the triangle. This one is not. So she should have done 8 squared take away 6 squared, because we were actually looking for a shorter side of this triangle. So she should have done 8 squared take away 6 squared. I'm going to put AC is the hypotenuse, not BC. And the next one, Roy is going to enlarge PQR with centre C and scale factor 1.5. He draws triangle XYZ. Explain why Roy's diagram is not correct. So if we're enlarging this triangle with a scale factor 1.5, we would expect all of the sides to be 1.5 times bigger. And also for the distance from the centre to the shape to be 1.5 times bigger. If we look at the minute, we can see that it is 4 squares away from C at that bottom point. 4 times 1.5 is 6. So we would expect it to be 6 away from C at the end. So actually this point here should be here. That's 1.5 times bigger. He's gone 1.5 from R, which is actually 2.5 overall. So that's no good. And let's just look. This is 4 tall. And he's gone 4, 8, 10. So it's actually 2.5 times bigger. He's actually done a scale factor of 2.5, not 1.5. He has used scale factor 2.5, not 1.5. Question number 10. Marie invests £8,000 in an account for 1 year. At the end of the year, interest is added to her account. Marie pays tax on this interest at a rate of 20%, and she pays £28.80 tax. So she had £8,000 in the account, and then something has been added on, the interest, and then of that, 20% of it has been taken as tax, and that is £28.80. So £28.80 is 20% of this amount, the extra bit that's been added on. If I want to know how much was added on then, the easiest way to do that, you could divide it by 2 and times it by 10. I'm just going to times it by 5. So £28.80 times by 5, you could divide by 0.2 if you really wanted to, is £144. So that is 100% of what was added on. This is 144. Now, what was the percentage interest rate? Well, all we need to do for that is say what percentage is 144 out of 8,000. So I'm going to use the fraction button in my calculator. 144 over 8,000, this was a calculator paper, is 0.018. And if I want that as a percentage, I'm going to times it by 100. And so that is 1.8%. That was the interest rate. 144 is 1.8% of 8,000. Question number 12. Patrick has to work out the exact value of 64 to the power of a quarter. Patrick says a quarter of 64 is 16, so 64 to the power of a quarter is 16. Explain what's wrong with what Patrick says. So the power of a quarter is not the same as a quarter of 64. So finding a quarter of something is not the same as doing the power of a quarter. The power of a quarter means the fourth root. So we actually need to do the fourth root, not find a quarter of it. So we're looking for something times something times something times something, or something to the power of 4 that is 64. So we actually need to do the fourth root of 64. Something times something times something times something that makes 64. And in my calculator, if I do that, there is a root button where you can do whichever root you want. If I put the fourth root of 64, I actually get 2.828. So that's what value you would have to times by itself, by itself, by itself to get 64. Question number 14. The diagram shows a rectangle ABDE and 2 congruent triangles. Congruent just means they're exactly the same. So the 2 triangles on the side here, they're both the same as each other. The area of the rectangle is equal to the area of triangle AFE, the triangle on the left, add the area of triangle BCD, the triangle on the right. and AB to AE is in the ratio 1 to 3. So this side, 1 to this side, 3 in that ratio. Work out the length of AE. Now, I've got a lot of missing information here, but I do know that this is true. So I can write an expression or an equation for this. I'm going to say that this side is x long. And if it's x, then this side is 3x. So therefore, what I can say is the area of the rectangle, x times 3x, base times height, is equal to the area of this triangle. Now, to get the area of that triangle, we don't have base times height. It's a non-right-angled triangle. We haven't got perpendicular sides, so we're going to have to use the fact that we know the area of a triangle is half AB sine C. Half AB sine C, so half times 24 times 3x, those are your A and your B, times sine 30. But I haven't just got one of those triangles, I've got two of them. So I could take that whole triangle and double it, which is quite nice because that's going to cancel out the half. So I've got 3x squared equals, now instead of doubling and halving, I'm just going to cancel those two out, 24 times 3x times sine 30. Now this was a calculator paper, so you're okay to type that in your calculator, but you might also know that sine 30 is a half. That could very easily come up on the non-calculator paper. So I'm just going to half 24 for ease here and say that 3x squared is equal to, let's take the 24 and the half and just write that as 12 times 3x, which is just 36x. So 3x squared equals 36x. Now, because this is a quadratic, I'm actually going to take it over to the left-hand side. 3x squared minus 36x equals 0. You don't have to. You could divide by 3, divide by x, but you're going to potentially lose a solution, and I'd rather do it properly. So I'm going to factorise now. 3x on the outside, brackets x minus 12 equals 0. So we've got two solutions. Either x equals 0, or this bracket is 0, x equals 12. Now in the context of this question, it doesn't make any sense for x to equal 0. That would mean that the rectangle doesn't exist. So we want to use the value x equals 12. And they wanted the length of AE. So if we know that x is 12, that's going to be that length. And so the length of this side is 3 lots of that. 3 lots of 12 is 36. So that was my answer for 4 marks. Question number 16. Here are the first 6 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. So I'm going to write it out a little bit bigger. Minus 1, 5, 15, 29, 47, 69. For a quadratic sequence, we're going to do the first difference, plus 6, plus 10, plus 14, plus 18, and then plus 22. And then because those values will be different for a quadratic sequence, we always do the second difference. Add 4, add 4, add 4, and add 4. And that should always be the same number. That number should always be the same. If it isn't, you've done something wrong, go back and have another look. Whatever that value is, you're going to half it. So if it's 2, you'll half it and get 1. If it's 4, you'll half it and get 2. And that tells you the coefficient, the number in front of n squared. So I know that this sequence is n squared. They've told me it's a quadratic sequence. If we're having to go to that second difference, we know that it's going to be n squared. And in this case, because we're halving 4, we know it's 2n squared. Now 2n squared is the sequence of all of the square numbers doubled. So 1 squared is 1, doubled is 2. 2 squared is 4, doubled is 8. 3 squared is 9, doubled is 18. 4 squared is 16, doubled is 32. 5 squared is 25, doubled is 50. And 6 squared is 36, doubled is 72. And now all I'm going to do is compare the difference from that sequence to the sequence I actually want. So to go from 2 to minus 1, we'd have to take away 3. To go from 8 to 5, we'd also have to take away 3. To go from 18 to 15, we're taking away 3. So actually, we haven't got any more work to do here. We can see that to get the sequence that we want, this one here, it's going to be 2n squared, subtract an extra 3. Sometimes this bit makes another sequence, and then you have to do the nth term of that and add it on. But in this case, it was just 2n squared, subtract 3 to get the sequence that we were interested in. Question number 18, show that 2x add 1 times x add 3 times 3x add 7 can be written in the form ax cubed, add bx squared, add cx, add d. So all we need to do here is expand the brackets. Now I'm going to start by multiplying out the first two brackets. 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is another x. And 1 times 3 is 3. Simplifying that, we get 2x squared, add 7x, add 3. Now we need to multiply that by our third bracket. So to do that, I'm going to start with the 2x squared. 2x squared times 3x and 2x squared times 7. So that's going to be 6x cubed, add 14x squared. Moving over to the 7x, I'm going to do 7x times 3x and 7x times 7. So that's 21x squared, add 49x, and now I'm moving over to the 3. 3 lots of 3x is 9x, and 3 lots of 7 is 21. So altogether now I can collect my like terms, and my final answer would be 6x cubed, add 35x squared, add 58x, add 21. So I've just collected those like terms there and collected those like terms there. And that's my final answer, expanding 3 brackets. Quite a nice topic. It does come up quite a lot, so make sure you're happy with that. Part B, and we've got a quadratic on the left, needs to be less than 9 over 25. Quite tricky this. Now there's a couple of different ways you could do this. I'm going to expand this out. So 1 minus x squared is 1 minus x times 1 minus x, which is 1 minus x minus another x, add x squared. So that expands out to be that. It needs to be less than 9 over 25. Now, turning this round, x squared minus 2x, add 1 is less than 9 over 25. This is a quadratic. I would like it to be less than 0 so that I can solve it. So I'm going to take 9 over 25 away from both sides, and imagine that 1 is 25 over 25. That makes it easier to do without a calculator. X squared minus 2x, add 16 over 25 is what we'd be left with, is less than 0. So now I'm going to solve it, and I'm going to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be 2 plus or minus the square root of 4 minus 4 times 1 times 16 over 25 divided by 2 times 1, or just 2. Typing that in my calculator gives me 1.6 when I use the positive, and if I go back and change that plus to a subtract, then I get 2/5 or 0.4. And those would be my two answers. So what does that mean? Well, that means that my quadratic crosses at 0.4, it has a solution here, and it has a solution here, 1.6. And therefore your quadratic, we would like to know when is it less than 0, so it's between those two values. Here, this part of the graph is less than 0. My final answer would be that my value of x needs to be between 0.4 and 1.6. Question number 20. Solve algebraically the simultaneous equations x squared minus 4y squared equals 9 and 3x add 4y is 7. So in an ideal world, we need to make x or y the subject of the linear equation. So with this bottom one here, I need to make it y equals or x equals. I'm going to go for y equals because I don't really want to be dividing by 3 and having recurring decimals. So I'm going to say 4y is 7 minus 3x. So y is 7 minus 3x all divided by 4. If I then square that, y squared is all of this squared. Now when we square something, when we square a bracket, we are timesing it by itself. So 7 minus 3x over 4 times 7 minus 3x over 4. So y squared is 49 minus 21x minus another 21x, add 9x squared all over 16. So y squared, let's just turn that round, is 9x squared minus 42x, add 49, all divided by 16. And I can now substitute that into my top equation here. So I'm going to say x squared minus 4 lots of this 9x squared minus 42x, add 49 divided by 16 is equal to 9. And let's expand that out, okay? So I've got x squared minus 36x squared minus 168x, add 196, all divided by 16. I've just times the 4 up here, equals 9. And then I'm going to times everything by 16. I just think that's the easiest way to do it. 16x squared minus 36x squared minus 168x, add 196. Now be careful because you're taking everything here away, equals 9 times 16, which is 144. Okay, so let's simplify that down. 16x squared take away 36x squared is going to be minus 20x squared. And then I've got add 168x because we're taking away a minus. Minus 196 equals 144. I'm going to move it over to the right hand side so I've got everything being a little bit more positive, a bit nicer. So that's going to be 0 equals 20x squared minus 168x. And then I've got 144, add 196 on the right hand side. So that is add 340. Everything there looks like it's going to divide by something, hopefully by 4. That would be quite nice. So let's go 0 equals 5x squared. 168 divided by 4 is going to give me 42, so minus 42x. And then 340 divided by 4 is going to be 85, so add 85. Now, this is giving me factorising vibes. I reckon it will, but I'm not sure that I'm going to be able to spot it. Let's have a go. 5x and x. 85 is 5 times 17. What do we think? 17 here, 5 here. Yeah, we've got it. There we go. 25 and 17 does make the minus 42. So if we make them both negative, there we go. X equals 5 and x equals 17 over 5 for this solution. Remember, you're trying to make the bracket equal 0. So 5x minus 17 equals 0 means that 5x equals 17 and x equals 17 over 5. That's how I've got that value there. Once you've got both of your x solutions, you're going to substitute them back in. And I'm actually going to use this formula here. That's the easiest way to get y. Y is 7. Take away 3 lots of x, all divided by 4. And I'm going to use my calculator. So I know the first value of y is 17 over 5. So in my calculator, I'm going to pop this equation, but I'm going to put that value of x in. So using my fraction button, 7 minus 3 lots of 17 over 5, all divided by 4. And that gives me a value of y to be minus 4/5 or minus 0.8. So those ones go together. And then for the other one, I just need to put 5 into that same equation rather than 17 over 5. And that gives me minus 2. So that was your final answer. Those two values, or those two pairs of values to solve the simultaneous equations. A very, very tricky question, that one. And it keeps going. Question number 22. The diagram shows a circle, centre O. AB is tangent to the circle at the point A. Angle OBA is 30 degrees. Point B has coordinates 16, 0, and point P has coordinates 3P, P. Find the value of P. Give your answer correct to 1 decimal place. You must show all your working. Okay, so we've got a point on the edge of the circle. We know that is going to satisfy the equation of the circle, whatever it is. So let's try and get this value here first. This is going to be a helpful value. If I can get that value, then I'm going to be able to get the radius of the circle, and therefore I'm going to be able to get the equation of the circle. So let's start by labelling this side as 16. We've actually got a right angled triangle here using the radius and the tangent. We've got 16 as our hypotenuse, and we don't know the opposite, but we quite like to try and work that out, okay? Got 30 degrees there as our angle. So let's use SOHCAHTOA. I'm going to use SO because I want the opposite, and I've got the hypotenuse. So if I do sine 30 multiplied by the hypotenuse, 16, that's going to give me the radius there. So I therefore know that that will be 8. Sine 30 is a half, remember? So if this side is 8, then that tells me the radius of a circle. Now the equation of a circle is x squared add y squared equals the radius squared. So x squared add y squared is 8 squared, so 64. So I know now that this is the equation of the circle, and if this value lies on the circle, it will make the equation true. So now we can say x squared add y squared is 64. So therefore 3p squared add p squared needs to equal 64. Now altogether 3p squared is 9p squared because you're doing 3p times 3p. Add another p squared equals 64. So I've got 10p squared equals 64. Dividing by 10, p squared is 6.4. So we're going to do the square root of 6.4, and that is 2.5298. So we've got p equals 2.529822, blah, blah, blah. And they want this rounded to one decimal place. So we will say that p is 2.5. A very tricky last question, a very tricky couple of last questions really, so well done if you followed on with either of those. As always, the topic list is on the paper. This is week 12 that we did this week. If you've got any questions or anything you want me to do more of, please let me know in the comments. I'd be more than happy to help. I hope you enjoyed it, and I will see you next week for week 13.